And today we would like to present our senior design project, which is an apparatus for remote control of humanoid robots, or ARCHR for short. Our overarching goal is to intuitively control humanoid robots remotely. So in 2011 in Japan, following a major earthquake, a tsunami disabled power supply and cooling of 3 Fukushima Daiichi reactors. Due to radioactive contamination, personnel were not able to enter the site to perform crucial tasks that would contain the meltdown. Robots did come to aid, but Japan was unsuccessful at utilizing them in the disaster area. In the direct response to the Fukushima Daiichi disaster, DARPA started the DARPA Robotics Challenge with the goal of developing ground robots capable of executing complex tasks in dangerous, degraded, human-engineered environments. What they were looking for is 7 capabilities, 2 of which are situational awareness and dexterity. Various humanoid robots participated in the first stage of the challenge and met these, but we noticed that it was difficult for the human to control these robots. This in turn inspired us to work on designing a controller that was easy to use and intuitive, while also providing the user with sensory information, so that it could be quickly deployed and easily operated in the disaster area.
Our system is comprised of 2 distinct components that work together either over a network or fully remotely. The first is a scaled physical controller of the robot that we call kinematically scaled. So if the user moves the controller's arm forward, the robot's same arm will move forward in the same manner. This allows for any robot to have a kinematically scaled controller, and regardless of the robot's size, big or small, and it will allow us to be able to easily control it. We've also implemented haptic feedback so that if the robot encounters resistance, the user will be able to feel that and understand the constraints. The second component is a stereo vision and virtual reality system. The video feed from the 2 cameras are overlapped in front of the user to give them a feeling of depth instead of using complex visual processing. And then the virtual reality system tracks the user's head movement so that if they look left, right, up, or down, the robot will look in the same direction. This fully immerses the user into the robot's area of operation and makes it feel like they are performing the tasks themselves. This meets our ultimate goal of being able to have a specialist in a needed field, rather than a specialist in robotics, be able to perform complex and technical duties.
So to test our design, we held 3 demonstrations over the course of 4 days to showcase our project and to get user feedback regarding our system and their experience with it. Users range from elementary school students, middle school students, college students with various majors, and even faculty members. So what we found from these tests is that our system is unique among other controllers currently in use, because even first-time users were able to intuitively and easily complete tasks in a short amount of time. So one would expect hours of on-site training or a need for certification to be authorized to control a humanoid robot, but here we are demonstrating that virtually anyone could have a full control over a robot upon first being exposed to it.
After the testing, we polled various users to see where they thought that our system would be able to be used, and the results are displayed above. So we decided to have a full-scale test of the robots, having 2 robots perform a cooperative task. As you can see on screen, the large robot is using his height in order to pick up a specimen that could be dangerous to a human. He's being controlled by a member that's there, but they could also teleoperate it. The specimen is then handed down to our custom robot, which utilizes its mobility in order to transport that specimen outside without the need of a person being there. These robots can be deployed in a variety of areas without having to be reprogrammed in order to operate in their environments, in their new environments. So they could be deployed to West Africa and be controlled by medical experts in order to not expose them to Ebola. In fact, the National Science Foundation has put out a broad call for ways to stop the spread of Ebola, and a version of our ARCHR system is going to be submitted as a method of doing just that. So we are greatly looking forward to the continuing possibilities of the uses for our system, and we will also have a display outside. Thank you so much.